Welcome back everyone to my channel Chemistry Made Simple for NEET. I am Dr. Subramaniam with a PhD in Chemistry. So today I am going to upload the second part of the most important MCQs of Chemical Kinetics Part 2. So already I have uploaded the first part of this important MCQs from this lesson. So here today we are going to solve some important sums also from this lesson. So here while I was sharing some tips for learning organic chemistry for NEET. So here you have got a chapter of organic compounds containing nitrogen. So from that chapter you have to focus mainly on the named reaction, as I already said: Gabriel phthalimide reaction, Hofmann's bromamide reaction, diazotization reaction, carbylamine reaction. Coupling reactions should not be missed, and preparations and reactions of amines. So with these you would be covering the entire organic chemistry for NEET, and also there are a few tips that could help you while studying organic chemistry. Always write and study the reactions. Many of the reactions are interlinked. You have to make a note of all such reactions. For example, in the chapter under reaction of alcohols, you will see that alcohol on oxidation forms aldehydes. The same reaction you will be studying under the preparation of aldehydes also. You have to maintain a separate notebook for named reactions. Then most importantly, understand the mechanism of reactions. This will help you to predict any products. Compare and study. Make sure you know the variations in physical properties among different functional groups such as acidity, basicity, boiling points and all that. And with those few tips I would like to continue with the first question of the second part of important MCQs of chemical kinetics. So what is the first question we have got to look here? First question is, which of the following is a factor that automobile engines use to increase the rate of its internal reactions? So A, concentration of fuel, B, viscosity of the fuel, C, surface area of reactants, and D, nature of the fuel. So option C, that is surface area of the reactants, is the correct choice. Automobile engines, they cannot change the concentration, viscosity or the nature of the fuel. What happens in engines? You inject fuels in the form of microscopic droplets so that it has larger surface area when it is fed into the engine as a steam. This allows the fuel, as when the larger surface contact area is there, the droplets will cause a stream and allows the fuel to burn rapidly. Okay, next question is, we are having sum here. Rate constant is given. It is 0.01. Then the question is, how much time does it take for 2.4 moles per liter concentration of reactant reduced to 0.3 moles per liter? You are having the 4 choice here. So what all factors are given? Rate constant is given. It is 0.01 per second. So that is K. K is 0.01 second. And for K value is already given in the question, and you have to remember one formula here. That is R is equal to 0.693 divided by K. So T half is equal to 0.693 by K is given 0.01. So that you will get it as 69.3 seconds. Then look at the relation connecting R is the concentration of R is equal to R to the power of 0 divided by 2n, and from this you can infer an equation for 2n, that is R0 by R. You know both the values. 2n is equal to R0, it's given in the question as 2.4, R is equal to 0.3. So 2n is equal to 8, n is equal to 3 because number of half lives, n is the number of half life. For one half life, T half, it is 69.3 seconds. So for 3 half lives, because we are getting 3 half lives, you have to multiply 69.3 by 3, that is 207.9 seconds. You write the sum and learn. Okay, and this is very easy. Just important what all data are given in the question, and write the correct equation. That is you have to remember R is equal to 0. That is an equation which you should never forget, 693 by T. That in that you have to substitute and remember this relation also. Okay, now moving on to the next question. What time does it take for the reactants to reduce to 3/4 of its initial concentration if the rate constant is given? That is 7.5 into 10 to the power of -3 per second. So here the value of rate constant is given, and they are asking for the time it takes to reduce to 3/4 of its initial concentration. 4 choices are given. Now how do you do this? Answer is 38.4 seconds. So given K is given 7.5 into 10 to the power of minus 3. Then this equation you have to remember, K is equal to 2.303 by T into log concentration of R0 by R. So you know all the values, 2.303 by 7.5 into, that is the value for K, 10 to the power of minus, we are taking the equation in the form of T. So 2.303 by 7.5 into 10 to the, that is K, the value of K. Log R0 by R is 100 by 25. So when you solve for this, you get T is equal to 38.4 seconds. Okay. Next question. A zero order reaction is 25% complete in 30 seconds. So the reaction, 25% of the reaction is getting over in 30 seconds. And by what time, how much time will it take to complete 50% of it? Answer is 40, 70, 50 and 60. The correct option is D. D is 60 seconds. So T 25 is 100 minus 75 divided by K. Okay, so K is equal to 25 by 30. Okay, so what is 30? It is completed in 30 seconds, that is the time. Okay, so 100 minus 75 is 25 by 30. So you know already K is 25 by 30. Now you remember this relation, A is equal to A0 minus KT. So 50% they are asking, and the time to complete 50% of that is 50 is equal to A0. A0 is 100 minus, then you are having the value of K into T. K is 25 by 30. T we don't know, we have to find out. So from this you find out a formula for T. In terms of T, write the equation. So T will be equal to finally 50 into 30 by 25, it is 60 seconds. Okay. Now next question. What is the integrated rate equation for a first order reaction? 4 options are given here, and the correct option is A. That is A concentration of A is equal to A0 E to the power of minus KT. Reaction of the first order is said to be, that is if the rate of the reaction depends on only one concentration term. So that is known as a first order reaction. So the integrated rate equation for the first order reaction in exponential form, just remember this, don't forget, this is very important. So this is the exponential integrated rate equation, because they will be giving the choice and ask you to identify the correct equation. So remember this always. Now next question is sum. So for a certain reaction, value of Arrhenius factor and activation energy both are given. Okay, and at 303 Kelvin, that is the temperature, you have to find out the rate constant if the reaction is first order. So value of R is also given. So you are having 4 options here. The correct option is C, that is 4.07 into 10 raised to minus 4. So what all values are given in the question? Arrhenius factor A is given 4 into 1013 collisions per second. Then the activation energy EA is given 98.6 kilojoule per mole. You convert it into joule per mole by multiplying it with 10 to the power of 3. T is also given 303 Kelvin. So now using this, log K is equal to log A minus EA, that is activation energy, by 2.303 RT. You know the values here. So log K is log A, that is Arrhenius factor, that is given. Okay, minus EA activation energy, this divided by 2.303, R is given, T is given. So just solve for the equation. So finally you get it, log K is equal to minus 3.39. So K will be this, you have to remember the values always, 10 minus 3.39. So finally you get 4.07 into 10 to the power of minus 4. Okay, now next question is decomposition of N2O5 in CCl4 solution when it was studied. N2O5 gives 2NO2 plus half O2. The rate constant of the reaction is 6.2 into 10 to the power of minus 4. You have to find the rate when the concentration of N2O2 is 1.25 molar. So values given here are rate constant. You have to calculate the rate constant of N2O5, that is 1.25 molar. Now option is D. D is 7.75 into 10 to the power of minus 4. So this is the equation given. So rate is K(N2O5), because here the reaction given is first order reaction. So 1.25 molar of N2O5 is there. So 6.2 25 into 10 to the power of minus 4 into 1.25, that will be 7.75 into 10 to the power of, rate is k into direct substitution. So easy, it's very easy to do. Okay, next question is find the formula to calculate the time taken for the completion of a zero order reaction. Out of these four formulas, which formula you use to calculate the time taken for the completion of a zero order reaction? So option is A, that is T 100% is A concentration of A to the power 0 by K. So when the reaction is complete, A to concentration of A to the power of 0 is 0. So K is equal to concentration of A to the power of 0 by T, or T 100%. So this is the correct option. So A to the power of 0 divided by K is the correct option. Okay, now next question. Half-life of a given reaction is doubled if the initial concentration of the reactant is doubled. What is the order of the reactant? Is it 0, 1, 2, 3? So what is the question? Half-life is of the reaction is doubled. The initial concentration of the reactant is also doubled. You have to find the order of the reaction. Okay, option is A, that is zero order reaction. Why? Half-life, that is T half, is the time required for quantity to reduce to half of its initial value. So in a zero order reaction, the half-life is directly proportional to its initial concentration. So the relation is like this: T half is equal to concentration of R to the power 0 by 2K. So here, since the initial concentration is also 0, option 0 is the A is the correct answer. Now next question, a first order reaction was 70% complete in 20 minutes. So you have to find out the rate constant. So the reaction was 70% complete in 20 minutes. What is the rate constant? 0.07, 0.06, 0.08, 0.09. Option is B. B is 0.06. So 70% complete, that is A is 70. Time taken is 20 minutes. Order integrated rate equation is like this, and you just substitute 2.303 by time 20 log 100 divided by 100 minus 70. When you calculate, you will get 0.06 per minute. Now what is the time taken to complete 75% of the reaction if the rate of the first order reaction is 0.023 per minute? So you have to find the time taken for what to complete 75% of the reaction, and they have given you the rate of the first order reaction as 0.023 per minute. Okay, now option A is the correct choice. 75% of the reaction complete, so A should be taken as 75. Rate of the reaction is given. First order rate equation, always remember this equation in a fraction of second you can solve for this. 2.303 by T, that is 0.023. You have to find out T, and you bring this K down here and move this T up here and reframe the equation, and just substitute the values. 100 minus A, 100 minus 75, that is 25. When you calculate, you will get 60.28 minutes. Next question, for the reaction X giving Y plus Z, the rate constant is this much. Find the what percent of X will be decomposed in 50 minutes. And for a particular reaction, the rate constant is given. You are asked to find out how much percentage of X will be decomposed in 50 minutes. Option is B, that is 82.44%. How do you get it? Rate constant is given in the question. Time is minutes, convert that into seconds, and just substitute in this equation. Here what you get is the log 100 by 100 minus A is K into T by 20. You are now rearranging the equation. Now log 100 by 100 minus A is, just substitute all these values, you will get 0.756. Then calculate the percent from here, you will get 82.44. Then the first order reaction is 50% complete in 30 minutes. Time taken for completion of 87.5% of the reaction. Is it 30, 60, 90 or 120? Option is 90 minutes. So for 50% to be complete, it is 30 minutes, that is T half is 30. 75% complete in 2 halves. So T is equal to 2 into 30, 60. 87.5% completed in 3 halves, half-life. So T is equal to 3 into 30, that is 90 minutes. Then for a pseudo first order reaction, what is the unit of the rate of the reaction? So always you remember, it is option A, first order, it is second raised to minus 1. Now which of the following reaction is an example of pseudo first order? And you are having 4 choices. Option C is the correct answer. C12H22O11 plus H2O gives glucose plus fructose. And sometimes the order of the reaction, as I already mentioned, it can be altered by changing the conditions, like taking one or more reactants in excess compared to the other. Molecularity of inversion of cane sugar is 2, but it follows the first order kinetics as water is present in excess in this reaction. So with that, we are coming to a conclusion of this very important topic of chemical kinetics, with most important numericals from the lesson is included here. Please, all of you, take care to work out all these sums in your notebook, and thoroughly you just do the calculation and arrive at the answers. And as always I say, please do like, share and subscribe to my channel. Share it with your friends as well. I'll be coming up with more numericals from all the lessons. Once we finish all the topics, I'll be writing in paper and help you and show you how to do the calculations, lengthy calculations in short steps. But that is not, the time has not yet come, because we have to finish all the units first before going through all those sessions. And don't forget to press the bell icon so that you will get notifications as soon as I post any new videos. Thanks for watching my video, and I'll be uploading another new session at the